So we're done with the topics for the first exam. The next topic is measurement of directions and angles. So far, we've had measurements of linear distances. So now we have angular. So we have a few terms here. Let's go with them one by one. First, your meridians. It's a fixed line of reference. We have three types, your astronomic, magnetic, and assumed meridian. Astronomic meridian is the direction of the line passing through the astronomic north and south poles and the observer's position. It is used for all surveys of large extent. While your magnetic meridian is the direction taken by the magnetized needle of a compass at the observer's position. Okay? And then the last one is your assumed meridian. It's an arbitrary direction taken for convenience. So most of the time we're using astronomic meridian. It's given. If not, we're using assumed. Okay. So to give you the difference, okay, I'll show you what that looks like. Okay. Directions and angles. Okay. So your magnetic meridian, or rather your astronomic meridian, is also called the true meridian. Okay. So that is what we have for your north and south poles. Okay. So this is what we use, your astronomic meridian. Here. Okay. Now, your magnetic meridian is not along this line. It's at a certain angle from this line. So the magnetic meridian would be over here. Okay? It could be on the left, it could be on the right. But basically, something like that. This is where the meridian is when we're focusing or when we're using your magnetic north and south poles. So let's label this as N sub M for magnetic and S sub M for magnetic. Now, the way or the amount that your magnetic meridian deviates from the true meridian or astronomic meridian is at an angle of declination. So we call this angle of declination. Again, it could be to the left or to the right of your true meridian, or to the east or west of it. Right? So that's the difference. And then assumed can be any arbitrary line for reference. Next, we have your units for measuring angles. You have first your sexagesimal system. For this, your circle is divided into 360 parts, and then its units are your degrees, minutes, and seconds. So this is what we've been using so far. Next, your centesimal system. The circle is divided into 400 parts, and the unit is grads. And then we have your radian. It's the angle, or rather for radians, the angle inscribed at the center of a circle by an arc length equal to the radius of the circle. So for example, if we have a circle, let's try drawing one. Okay. So let's say we know its radius r, okay, and then we're gonna use an arc length r as well. Okay. This is your r. This is 1 radian. Okay, arc length equal to r. The angle subtending that. Subtending meaning the opposite of that. Okay, and then the mil. For mil, circle is divided into 6,400 parts. So all in all, these systems give you conversions. Okay, so 360 degrees equals to pi rad. We already know that from your previous math classes or even physics classes. And then now it's also equal to 400 grads and 6,400 mils. Right, so this just to give you how to convert different angles to different units and systems. Now next, we have what we call an azimuth. So azimuths are the clockwise angles from the north or south end of the reference meridian to the line in question. Okay. So we have forward and back azimuth. So their values differ by 180 degrees from each other. It could be from the astronomic, magnetic, or assumed reference line. Again, it depends on the meridian used. So if you use the astronomic meridian, you have an astronomic azimuth. If you have, or you're using magnetic meridian, you'll have a magnetic azimuth. For example, on the drawing to the left, okay? For us, for our class, moving forward, our forward azimuth will always be from the north pole or from the north line. Okay, so for example, for line B, forward azimuth is 50 degrees. Okay, again, our reference is the north line. Forward azimuth of line C is 160 degrees. Forward azimuth of line B is 285 degrees. Backward azimuth, that's just 180 minus the angle in question. Okay. So as you can see, they always differ by 180. So for example, the back azimuth of letter B is 130 degrees. All right. So to illustrate the back azimuth, that's just if you extend this line to the back and then going from the north and then measure that angle. Okay. For example, to illustrate again, so this is the forward azimuth. And then let's call this one your back azimuth. And okay. So this is your line. I'm just gonna extend it backward, and then this is your back azimuth. So as you can see, that's why their difference is always 180, because when you add them, it's 180 degrees. Okay. Next, bearings. Again, you might have heard bearings from physics. So bearings are the smallest angle with which that line makes with the reference meridian. It cannot be greater than 90 degrees. So it's always measured in relation to the north or south ends of the meridian, and then it can be astronomic, magnetic, or assumed depending on meridian used. So once again, if you're using an astronomic meridian, you'll have astronomic bearings, and so on and so forth. So for example, here, okay, for line C, the bearing will come from the south pole, because that's going to be the one that gives an angle less than 90. If we're taking the angle from the north, that's 160 degrees. And again, cannot be greater than 90. Okay? Okay. How about letter D, angle D? Can anybody give me what is the bearing or the angle from the north or south pole? Again, D, angle D. Okay, got that. Correct, Diego and John. So the skull rose. Oops. Okay, for the skull rose. Okay, correct. The answer is 75. So that would be this angle. And that's 360 minus 285. So the bearing of angle D would be north 75, then going to west. So north 75 degrees west. Okay. So that's a bearing. Next, the compass. So the compass needle lines up with the magnetic north. So if you've ever used a compass, it's not pointing to true north. Okay, it's pointing to magnetic north. And as I've mentioned earlier, those are different. And then magnetic declination. So again, it's the angle between magnetic north and astronomic north, as you can see here. And then lastly, we have traverse angles. So traverse is a series of straight lines that are connected together. It can be closed or open. So closed traverse are used for boundary lines for a piece of land or piece of lands. Open traverse are for highways and railroads. Next, within your closed traverse, we have interior and exterior angles. So interior angles are enclosed by the sides of a closed traverse, while exterior angles are the opposite. They are formed on the outside of a closed traverse. And then the last two are your angle to the right and your deflection angle. Angle to the right is clockwise, and then it's a clockwise angle between the preceding line and the next line. For example, here, okay, preceding line is AB, next line is BC. So angle to the right is from this point going to this point. Same thing here, preceding line BC, next line CD. So angle to the right would be from this point to the next line. Okay, and then we also have your interior exterior. So if we have this closed traverse, interior here is here inside, exterior is here outside. And then finally, deflection angle, an angle between the extension of the preceding line and the next line. So for example, AB, I'm gonna extend that line, okay, and then get it to the next line, and this is your deflection angle. So those are your types of angles. So do you have any questions so far about the concepts and terminology? Please answer in the chat. Okay, since you don't have any questions, let's have a few examples. Number one, from the traverse shown below, compute the azimuth and bearing of side BC. So let's see if I can copy this so that it's gonna be easier. Okay. And then let me just. Okay. Okay. Once again, we're solving for number one, getting bearing and azimuth of BC. So let's start with azimuth. Okay. Again, this is our point. So again, for us, azimuth is taken from the north line. Okay. So in some books, or even for some other professors, that azimuth is taken from the south. Okay. So it's arbitrary. It's not arbitrary. It could either be north or south. But again, for us, please take note, our azimuth is taken from the north line. Okay. So now that we know that, to get the azimuth, it's basically drawing a vertical line, okay, and then figuring out what this angle is. Now, the easiest place to place your line or reference line would be at the beginning or end of your segment. And for this problem, since what I'm given is the bearing of line AB and the angle from AB and BC, I'm gonna put my reference line here. So this is an example of your assumed meridian. So I'm gonna assume this is my north, okay? And then this is the angle that I need. So to get that, we'll use what we have. So the bearing of line AB is north 30 degrees, 35 minutes east. So that means if I draw a line here, okay, so this is north, it's gonna go east. So east is this way. So that's this angle. Okay, and this is actually equal to your 30 degrees, 35 minutes. Okay. Now remember, if I extend this line, we have your deflected angle. If I do this is what we call your deflection angle, as you can see. So let's call this theta. And now, in order to get my azimuth, I need to solve for theta and whatever this line is or angle is. But if you look closely, this angle is the same as this angle. Why? So let me isolate that. Remember, if we have parallel angles, their value is equal. So theta 1, theta 2, parallel angles are angles from the same line. So this is the same line and then the same vertical line. So they're parallel, therefore they are equal. So here, this is also 30 degrees, 35 minutes. So now the only thing I need to solve for is this theta. Okay? So to get theta, can anybody tell me how to do that? Very good, Michael. What do you mean minus 180? The specific. Correct, KB. Okay. So if you look here, right, this is a straight line, and then this is 180 degrees. Theta is actually the supplementary of 85 degrees. So therefore, in order to get theta, that's just 180 minus 85, 14. Please solve. What's the answer? Correct, Jan. And, oh, sorry. Correct, KB and John. So for this guy, Escobar, FP. Okay. It's 94 degrees, 46 minutes. Wait lang. Tama. 94 degrees, 56, 46 minutes. Okay, but that's not the azimuth. To get the azimuth, as I mentioned earlier, that's theta plus this. Theta plus 30 degrees, 35 minutes. Please solve. What's the answer? Okay, correct. Zaira, Penoliar, and Maro. Kasople, Penoliar. Oh, by the way, Maro is actually the highest in your quiz one. She got a 99 out of 100. So very good. She got a 99 out of 100. Very good. Maro Gabriel. Highest for quiz one. So correct. The answer is 125.21. Okay. So azimuth is just an angle. Next, I need to get the bearing. So once again, bearing is the smallest angle from either the north or south line. So from here, this is your north line, this is your south line. Where should we take the angle from, north or south, to get bearing BC? Correct, it's south. Alexandria and Kian. Kiban, Labra. To the Arengo. So south. Because again, if you take it from north, that's actually the same as your azimuth. That's 125. And bearings can't be larger than 90. So we're taking it from the south. Okay. So that would be okay. So I'll mark it here. Let's call this your phi. Okay. That's our bearing. And then to get bearing, I need to get phi rather. Okay. That would be, you already know this is 180, right? So 180 minus theta, I'm left with 8514. Or I'll just use this. 8514, I need to subtract this angle. Can anybody give me what is this angle equal to? By looking at the drawing, can you figure out what is this angle? Mhm. Okay, correct. Diego and Geraldine. Lazaro Cruz. Cruz. So correct, it's 30, 35. Because again, if you figured your theorems on angles, these are alternating interior angles. So yeah, this is theta 1, this is theta 2, alternating interior, therefore they're the same. Could also be written like this, and theta 1, theta 2. Alternating interior angles are equal. Okay, so therefore that is also 30 degrees 35. Please solve. What's the answer? Correct. Kian, Geraldine, Lazaro, Kiben. Q. It's 5439. Okay. Ah, that's not our answer. Okay, that's just the angle. I need bearing. And to write bearing, you need to include the direction. So to get direction, just figure out where you took it from. It's either north or south. We've established that we got it from south. So that's south. And then your angle 5439. And then observe it went to the right, and that's east, right? This is west, east. It went towards east. So this is just east. Okay. And that's our bearing. And that's it for number 1. That's how you take azimuth and bearings. Do you have any questions? Please answer in the chat. Okay, great. No questions. Let's move on to number 2. Okay. Okay. Example 2. The magnetic bearing of line AB was recorded as south 43 degrees 30 minutes east in 1888. If the magnetic declination was 2 degrees east, what is the astronomic bearing of the line? If the declination is now 3 degrees west, what is the magnetic bearing of the line today? So first, I'm going to draw what's happening here. We have a line AB with this bearing, but it's a magnetic bearing. Therefore, it's not the true bearing. Therefore, the angle of declination or magnetic declination is 2. Okay? So in order to solve for this, you have to establish first your true meridian or your astronomic meridian. So let's draw that. So this would be my north and south. Okay? And then next, let's draw your magnetic meridian. So to draw that, you're going to follow how it declines. So magnetic declination, 2 degrees east. So from the north line, okay, we're going to go 2 degrees east. And that's this way. Okay. So measure out 2 degrees. Okay. And that would be your angle of declination. Okay. And then, let's call this your magnetic north, magnetic south. Okay. And now let's get line AB here. So line AB, from that magnetic bearing, because as you can see, this is a magnetic bearing. South, 40 degrees, 30 minutes east. So you're going to go from that magnetic south. Oh, this is S. Magnetic south. So you're going to go from this line. This is your line AB. This is your reference line. And then 40 degrees, 30 minutes east. So this way. It's going to go over this angle because that's just 2. Okay. So let's say here. Okay. This is your line AB. Okay. Or A could extend somewhere here as well. Okay, but I'm gonna cut it short here just to make our drawing cleaner. Okay, so I'll just put my A here. Bakit yung magnetic north 2 degrees from the north? Because that's given. The magnetic declination is 2 degrees east. And magnetic declination is the angle between magnetic north and astronomic north. So this is my astronomic north, declination 2 degrees east. That gives you the direction. So it's towards east. So this is where your magnetic north is. Okay? Okay. So now what we want, this is given. Okay, let's write that given. 4130. 41 degrees. 30 minutes. Okay? And then the question is, first, astronomic bearing of the line. So when we're looking for astronomic bearing, you want to get our measurements from the true bearings. So from this violet line, again, this violet line is your astronomic north or true north and south line or true meridian. So to get bearing from A to B, that's this line over or this angle over here, and that's your theta. Or let's call that theta. And then to get that theta, just look at our drawing. Okay. This total thing is 4130. Okay, if I can figure out this and subtract that from here, I can get theta. And then if you remember your vertical angles or opposite angles are equal. If this is 2, this is also 2. Okay? So again, vertical angles, let's say you have something like this. Theta 1 equals theta 2. So now we've recalled 3 theorems on angles. First theorem was your parallel angles, they're equal. Next theorem is your alternating interior angles, again they're equal. And this third one is vertical angles, they're equal. So take or remember all of those properties or when your angles could be equal. So that's 2. So now it makes it easy to figure out our theta. That's just 41. And this is easy to solve. What's that 41? Oh, that's 43, right? 43. Okay. I read it wrong. 43 degrees. 43 degrees, 30 minutes minus 2 degrees. That's just 41. Right? 43 minus 2 degrees. That's just 41. 30. We're not done. We're looking for bearing. Okay. So therefore, to get bearing, again, you're going to get your reference line. In this case, that is south. So this is south, and then just copy the value of your angle, 41 degrees, 30 minutes, and it went to the right. Again, that's east. Okay. So that's how you write your bearings. Okay. So that's the first part. The next part, if the declination is now 3 degrees west, what is the magnetic bearing of the line today? So we have a new one, 3 degrees west. So meaning that's going somewhere here. Yeah. So let's try drawing that. So 3 degrees west would be between here, okay? Because if you extend this line AB, okay, this is theta as well, and theta is 40 degrees. This is 40, so your magnetic south or magnetic north and south would be between that. So let's say somewhere here. Okay. And this is your 3 degrees west. So this is your new magnetic north, magnetic south. And then what we want again is magnetic bearing of the line today. So our reference line is this blue one, the new magnetic bearing. So meaning this is what I want to look for. And let's call that phi. Okay. So can anybody tell me how do I solve for phi? Okay, what do I subtract? From, okay, completo. What am I subtracting? Correct. RDL. Oh, tama. RDL and Jan. Lahom. So RDL. Lapid lang. Okay. We subtract because again, if you look at the drawing, this is why it's important to make an accurate drawing. I need phi. I need this. Okay. If I manage to figure out what this is, I'll just subtract the two and I'll get phi. Okay. Phi is this angle. But if you've noticed, phi is actually vertical to this angle. Therefore, phi is equal to 3 degrees. So this is equal to 3 degrees. So therefore, theta, okay, that's theta minus 3 degrees. Again, that's easy enough because that's just 41 minus 3. So that's 38. So 38 degrees, 30 minutes. And once again, we're not done. That's not a bearing. To get bearing, you're going to start with the reference line, which is south, and then your value, 38, 30, and then where it went. So this is your magnetic It still went towards east. So this is east. Okay. So that's it for number 2. Now, the reason why we're given a year here, you might be wondering what's the significance of that. The significance of that is because the amount of declination your magnetic meridian has increases or decreases over time. Okay, so for 1888, it was 2 degrees. And as you can see now, after several years, it turned into 3 degrees west. So it's been rotating from east to west. Okay, so if what's given is your magnetic meridian deviates 1 degree every year. So if we're starting with 1888, okay, so let's say magnetic declination is 2 degrees east every year. Okay. So let's say by 1889, the total magnetic declination now is 4 degrees east. Okay. Or if we say the magnetic declination is 1 degree west, okay, every year, and right now it's 2 degrees east. When we get to 1889, so from 2 degrees east, you're going 1 degree west. So the total declination now is 1 degree east. Okay, so to make that clearer, this is at 1888, this is 2 degrees, and let's say our amount of declination per year is 1 degree west. So after 1 year, it's gonna go west, so it's gonna go here. So this is at 1889. This is by 1 degree. Yeah. Therefore, total declination is now 1 degree, still towards east. Okay, and then eventually this will move towards west, and then this just figure out what this is, and that's why after several years, this turned into 3 degrees west. Okay, and so that's the importance of the year. So do you have any questions for directions and angles so far? Please answer in the chat. Everyone, please answer as well. Okay, great. So that ends the lecture portion of this meeting.